Hi, I am Nihal Siddham Shetty, currently pursuing my Masters in Arizona State University in Computer Engineering. I have completed my BTech in Srinidhi Institute of Science and Technology in Electronics and Computer Engineering. My keen interests are projects and researches related to real-time embedded systems, especially in RFID technology. We have got a paper published in International Research Journal of Engineering and Technology on lane control using laser and RFID technology. The main aim of the project or the research is to detect the vehicles which are getting onto the opposite lane and to overspeed or overtake the vehicles. Because of these, many accidents are caused, so I wanted to detect these vehicles and impose a fine on them. When I thought of controlling this, the first idea which struck into my mind is image processing. Image processing has its disadvantages, like in various climatic conditions like snow or fog, the image gets distorted and you need to use Gaussian filters or Bayes filters to get the image properly and impose a fine on them. So instead of that, I thought of an affordable and cost-effective solution using laser and RFID technology. The concept behind the research is every vehicle is attached with an RFID tag which holds the vehicle's number or the vehicle's owner's name, etc. And a laser is projected onto an LDR on the line of separation of the road, and it may be at any distance. Whenever a vehicle crosses or obstructs the laser, the RFID readers which are placed along the road are activated, and the data from the RFID tags which are attached to the vehicles are read from those RFID readers, and then it is sent to the server using ESP8266. Finally, the fine is imposed. Since these are placed on the roads, we can attach solar cells or solar panels so that we don't need to keep a battery too. Also, since the vehicle also has an RFID tag, we can, whenever the driver crosses the lane, we can send him a signal like a beep sound in the car or vibrate the seat he's sitting on, so that the driver will also get notified that he's crossing the lane. This will help to reduce many number of accidents, and also since I have faced a near-death experience because of this or missed the accident by inches, I came up with this solution. The research which I have developed just works on 9 volts, and the power consumption is very less because I am activating the RFID readers which are placed on the road only when the laser is obstructed. So I am using a divide and conquer technique so that the power consumption will be very low. I have used STM32-bit microcontroller and ESP8266 and RC522 RFID reader. We have used passive RFID tags to attach to the vehicles at a convenient position where the reader can read it efficiently. From childhood, seeing my father who is into research and development, I have developed an interest in research. Always I follow one motto, TAD, which stands for Think, Analyze and Develop. Any matter, anything you see, we need to think, analyze it, and then you can implement it, or you can rethink to develop an efficient solution. That's how the research works, and people in India are afraid of doing researches because of the proper funding and mainly because of the lack of encouragement. I have received encouragement from my father, SP Chandu, and his colleague Hanmantraj sir. The concept is to combine 3 various systems, that is laser detection, RFID technology and sending data through ESP. The laser is projected onto an LDR in parallel above the lane separation line on the roads. Every vehicle has an RFID tag attached at the bottom of the vehicle. This tag contains the data of the vehicle, like the vehicle number and the owner's name. Whenever a vehicle crosses the line The LDR sends a signal that turns on the controller STM32-bit microcontroller. This controller then activates the RC522 RFID reader and the ESP8266. The RFID reader reads the data of the vehicle from the RFID tag attached to it. This data is then sent to the database or server by the ESP, where the challan or a fine is raised on the vehicle. This all happens in a span of seconds. Also, it is cost efficient. The system just works on 9 volts battery and hence consumes very less power. And if you replace this 9 volts battery with the solar panels or solar cells, the power consumption is reduced drastically.